Chapter 4, Section 1, The Nature of Energy. The two big questions are how are work and energy related, and what are some forms of energy? How are work and energy related? Have you ever watched sailboats on a lake? They move across the water without an engine to power them. A sailboat moves because the wind pushes it. Wind is moving air, and because it is moving, wind has energy. Energy is the ability to do work or cause change. Work. Work is done whenever a force exerted on an object makes the object move in the direction of the force. Work is a transfer of energy. For example, moving air exerts a force on a sailboat, and the sailboat moves. The air does work on the sailboat. When this happens, some of the energy of the wind is transferred to the boat. The amount of energy the wind has can vary. On some days, the wind blows faster. The wind can then transfer more energy to a sailboat, and the sailboat moves faster. On other days, the wind has less energy, and the sailboat will move more slowly. The moving sailboat has kinetic energy, the energy an object has because of its motion. The faster the sailboat moves, the more kinetic energy it has. Energy can also be stored. Stored energy is called potential energy. If the wind dies down, the sailboat engine can be used to move the boat. Potential energy stored in the fuel becomes the kinetic energy of the moving boat. Power is the rate that work is done. Since work is a transfer of energy, another way to say this is that power is a transfer of energy over time, or the rate that energy is converted from one form to another. Energy is typically measured in joules, so the unit for power is joules per second, or watts. Mechanical energy. An object's combined kinetic energy and potential energy is called mechanical energy. Mechanical energy equals potential energy plus kinetic energy. Mechanical energy is the form of energy associated with an object's motion, position, or shape. For example, the diver shown in Figure 2 has mechanical energy because he is moving and because of his height above the water. Like all forms of energy, an object with mechanical energy can do work. For example, the diver does work on the diving board when he jumps on it, causing it to bend. Then the diving board does work on the diver as it pushes him upward as it returns to its normal shape. He has both kinetic energy and potential energy. A bicyclist moving along a flat path has a potential energy of 0 relative to the ground. In that case, her mechanical energy equals her kinetic energy. A book sitting on a shelf is not moving, so its kinetic energy is 0. The book's mechanical energy equals its potential energy. Gravitational potential energy. The mechanical energy of position, or gravitational potential energy, depends on an object's height relative to a reference point, such as the ground. The higher an object's position, the greater its gravitational potential energy. Elastic potential energy. Mechanical energy due to an object's shape is called elastic potential energy. When you push down on a spring, for example, you change its shape. An object that is compressed or stretched out of its normal shape has elastic potential energy. This energy is released when the spring returns to its original shape. What are some forms of energy? So far, you have learned that objects have kinetic and potential energy due to their motion, position, or shape. All objects are made up of tiny particles, invisible to the naked eye. Such particles have kinetic energy since they are constantly moving. Together, the particles also have potential energy as a result of their interactions. Forms of energy associated with particles include electrical energy, nuclear energy, electromagnetic energy, thermal energy, and chemical energy. All these forms of energy can be used to do work. Electrical energy. Electrical energy is the energy of electric charges. Stationary charges have potential energy. Moving charges have both kinetic energy and potential energy. Electrical energy runs computers, televisions, fans, toasters, and other appliances. Nuclear energy. Nuclear energy is potential energy stored in an atom's nucleus. Nuclear reactions in the sun produce sunlight. Other nuclear reactions generate electricity in nuclear power plants. Electromagnetic energy. Light is an example of electromagnetic energy, a form of energy that travels through space in waves. X-rays, radio waves, and microwaves are other examples of electromagnetic energy. The sun and stars give off electromagnetic energy. Thermal energy. Thermal energy is the total kinetic and potential energy of the particles within an object. These particles are always moving, so they have kinetic energy. The warmer an object is, the faster its particles move and the more kinetic energy it has. The way the particles are arranged gives them potential energy. So all matter has both kinetic and potential energy, even at rest. Chemical energy. Chemical energy is potential energy stored in chemical bonds. This energy can be released during chemical reactions. When certain chemical bonds are broken, energy is released. The energy you use to move, think, and grow comes from chemical energy in the food you eat.